Hey everybody, welcome to the PC Perspective Mailbag. I'm your host today, Ryan Schrout. Quick reminder, obviously we're here to answer your questions. If you leave us your questions either on the YouTube video here, we'll go through those and collect them and put them in a sheet so I can actually remember to read them and answer them hopefully for you. Or you can leave them on PCPer.com on the post with this video embedded. Both of those locations will work. If you didn't listen to our podcast this week, you may have missed that we do have merchandise available if you want to buy PC Perspective t-shirts. If you go to teespring.com/stores/PCPer, teespring.com/store/PCPer, you could buy a t-shirt with the PC Perspective logo on it, or Death Wish Raid, or Hot Dog Down a Hallway. Any of those exciting shirts that you remember from 2011. You can buy those. So thanks. We've had a lot of people ask, so there we go. I think we've had questions people ask on this mailbag show, so now we've addressed it. Let's get to the questions. Joe Rodricks asks, since I can't afford a decent GPU, is it possible to turn an external GPU enclosure, Thunderbolt 3, into something useful, like Massive RAID or something else fun? Yeah, we get a lot of questions about this type of stuff, all related to not being able to buy graphics cards or build systems because of it. You could totally use that Thunderbolt 3 dock for external storage, right? You could put a PCIe SSD in there. We were talking with Alan before, probably wouldn't bother putting a 900p in there because you're going through enough extra hops that some of the low Q-depth latency improvements that you would see in it may be reduced quite a bit. So go with some kind of larger capacity, still very fast NVMe PCIe drive. That could work. You say massive, Joe, you mentioned Massive RAID here. You could put a RAID card in it, but then you'd have to connect hard drives to that, and I'm guessing your Thunderbolt 3 dock doesn't have space for a lot of hard drives, so you'd have to have, you know, SATA or SAS cables coming off the back of that controller up to maybe you've got some of those multi-drive docks that should be installed into a case, and you just run the cables and power into that. You got to make sure you got to have enough power cables coming from that dock as well. This could get very complicated. I would not recommend it. You're basically getting into spaghetti style system design as well. I mean, technically, you could put almost anything in there that is PCIe connected. You could put a sound card in there. I don't know why you would, right? If maybe you're connecting this up to a laptop or something, you could do that. But I don't really have a whole lot of options for you other than that storage. Next question comes in from Azularus. Asks, do you think SoCs could potentially be a viable replacement for desktop CPUs and GPUs for gaming in the future? A couple of quick things on this. First, the term SoC, I know what you're referring to here is mobile SoC, things like Qualcomm Snapdragon, Samsung Exynos, MediaTek parts, those types of things, or Apple SoCs. However, I would say that most CPU vendors now, both AMD and Intel for the most part, are starting to call their parts SoCs as well, because they are system on a chip. They do integrate Southbridge functionality, which is even an outdated term in and of itself. They do integrate like storage and connectivity and all those types of things. But I do understand what you're talking about. Could those be replacements for desktop CPUs and GPUs? It depends on what your definition of the desktop, platform is. Do I think that eventually mobile or processors and graphics systems that were targeted at mobile could eventually grow to a performance level that the vast majority of people would be totally comfortable using them as their everyday computer? Absolutely. I think we're closer to that than you might think, right? If you look at what Apple is doing with their iPad line, if you do see what Qualcomm is doing with its Snapdragon on Windows, right? They're bringing the Snapdragon 835 processor, powering a mostly standard Windows 10 variant, right? So you're not going to be gaming on that, but it is offering a replacement for a desktop CPU and GPU for standard consumers. Now, if you get into gaming, it's a different type of discussion, because the real question you're asking is, will we ever get to a point where the graphics computing power we have today is good enough, right? We're no longer looking to find more graphics horsepower. It may feel like we're already there because we haven't seen any new GPUs in a long time, but that's a totally different phenomenon that is occurring or causing that. So my general thought process is we're still a decade away from where suddenly GPU compute power doesn't need to accelerate any, that we can no longer make better experiences for that. And because of that, you know, mobile will still increase, but so will desktop. And I do think that gap will eventually close. And the spot we're at today, how many years will it be before a mobile device, a mobile SoC, is capable of matching that performance? Maybe 5 years, maybe a little bit less, maybe a little bit more. So it's all kind of relative about what your state of where we will eventually be, because I don't think graphics processing is going to be slowing down. Excuse me. Question from 1W1W1W1W1, which is maybe the perfect Twitter handle, asks, why isn't AMD taking over the server market with EPYC? Changing the platform and mindset of IT and corporate enterprise deployments is not a quick process. If you've ever worked at a large company, you understand that even if the new idea is obviously the better idea, things have to happen. You have to have budgets. You have to have meetings to deploy those budgets and to separate them out. Then you have to approve these things. Then you have to buy some test systems. You're going to have to validate that they work with your software and your infrastructure, and then you're going to roll them out slowly. EPYC is kind of in that space, right? It is. You know, it wasn't just last month that we saw Dell announce its first PowerEdge systems using the EPYC processor, 2 or 3 machines, I guess. And so now system vendors, or I should say, you know, solution providers will now be able to buy those servers, test them, see what advantages they offer in performance per dollar, performance per rack unit, power efficiency, all that, and see where they implement them in their space. It's not as quick as a desktop or a GPU replacement cycle where it's an easy, well understood thing. It's also still important, even as good as EPYC can be in some places, to note that the number of processors it offers and the number of, you know, subgroups, subsections of the server space is really small compared to where Xeon is, right? Xeon has Xeon D through Xeon Scalable, all the way up to super high core count, down to low core count, different wattages. EPYC's portfolio is much smaller than what Xeon is, and because of that, and even by AMD's own admission, based on some workloads, it can't even address a whole lot of the spaces that Intel addresses. And that's not their goal for this one. Their goal was to get back in the game. And when your competitor has 99% market share or so as of last year, then it's easy to find. What you do is you find the place where you can make the most impact with the least investment, right? With the minimal amount of work, and you target that first, and then you grow from there, right? So AMD is all about, at this point, like growing that revenue. They understand that not only is it not possible for them to try to take over everything all at once or to get back to 25-30% market share that they were once at, it's just not a good idea to try to do that. You spread yourself too thin, then you do nothing well, as opposed to doing the one thing that you should do very well. Next question from Balthazar 2K4 asks, does the CCX latency across Infinity Fabric on a 1950X Threadripper processor negate any performance benefit of using an Optane 900p versus a standard NVMe drive for an OS drive? I think it's fair to say that the CCX latency will have some impact on peak performance of the 900p, but I don't think it's enough. No, I would not say that you would be negating any performance benefit from using a 900p over an NVMe drive. Keep in mind that when we're measuring latency of the CCX, we're talking about nanoseconds, and when we measure the latency of a storage drive like the 900p, we're measuring it in tens of microseconds. Or at least microseconds, right? So you've got 3 orders of magnitude between those. Now you're compounding things a bit because you might have to make multiple hops across the Infinity Fabric or what have you. So it's not simply an order of magnitude times 3, but it is worth noting, right? Yes, the CCX latency in the Infinity Fabric is going to have impact, but no, it's not enough to negate all the advantages that you get in those workloads where the Optane drives do show those advantages. Those advantages will still be there. And it's also important to note that a lot of this is still in flux because of Spectre and Meltdown and those patches. We don't yet know how they're affecting the Intel platforms, if or to how much of a degree they will affect the AMD platforms, right? Because remember, those Microsoft patches are still being applied, and at least the initial rollout of them on the Linux side, they were bucketing in the AMD processors to have to go through the workaround as well. I don't really know if that's the case yet for Windows, but it's something that we're going to try to figure out as well. So, and again, still trying to get to that finalized space where everybody says everything is secure, whereas performant balances were going to be for this, and now figured it all out. Trust me when I say Intel is desperately trying to figure all this out internally as well. Fake Ian asks, many laptops charge via USB-C now. Could you elaborate on how safe it is to use such a charger with a smartphone? I must first say that you should never take any of my advice in terms of power, charging, electric, or whatever. If you blow up your phone, your device, your house, yourself, not what we can handle, not our problem on there. That being said, I have charged my phones with a USB-C charger from a laptop, and I have charged my laptop through USB-C chargers meant for my phone. As far as what standards are in place and kind of like handshake policies are in place for that, I'm going to admit I don't know exactly what it is, but USB PD, power delivery standard, kind of set some of that, but not all devices are adherent to it. We've had many USB-C chargers throughout the office over the last 6 months to a year. And while we just assumed every charger would charge every device, it doesn't always work that way. So we've definitely had cases where some laptops don't work with another vendor's USB-C chargers. But the opposite is true, right? That you can swap that and they would charge. So some laptops seem to be a little bit more accommodating to that, and some chargers seem to have different capabilities when it comes to that. For your phone, I'd be a little bit more sensitive than I would kind of just swapping the power cables around than I would with laptops. Laptops, I think it's just generally safe to try it and see if it works, and if it doesn't, then find a different charger. For your phone, check the voltages. The power bricks are going to tell you what their options are. They're going to tell you, how low they can go down to. If the charger has a 5-volt option or goes down to that low, then it should be okay. But please don't blow up your phone and email me about that. I don't want to have to deal with that. Topical question from Josh in Droid asks, any Spectre Meltdown huge concerns, or are Spectre or Meltdown huge concerns for the average user? If so, are the OS level patches enough to protect users with older hardware who won't be getting firmware updates? So I assume what Josh is asking about here is more of the security side as opposed to the performance side. The OS level patches, I believe, protect you from the security side. What the firmware level patches do, the firmware updates and microcode updates, is give the processors the capability to run those reduced performance functions a little bit faster. So I think from a security concern, the patches and software are there. The patches and the browsers are in place as kind of a worst case scenario, and the microcode updates kind of augment them towards the performance angle. So my expectation is that you don't have to worry about them from a security standpoint. Now, from a performance standpoint, that's where the concern would come in. If you're on an older platform where your motherboard vendor or your OEM has decided they're not going to update that system, which sucks, I get it. You can definitely see both sides of this. If everybody had to go update every system that existed for the last 10 years, this would be a very costly, very expensive thing to do, and you don't even know how many users you're actively affecting with that. When you don't have the microcode updates in combination with the OS updates, that's when you may see more significant performance degradations that way. So we have some old systems here that maybe we'll start to dive into and see what happens. Like this PC that I'm recording this on is a 3350p processor, so clearly in that realm of things we could check in and analyze. But from a security standpoint, I think we'll be okay, and I'm including myself in that bucket as well. Next question comes in from Like onions. I don't understand why the names Volta, Ampere, and Turing are all being talked about at the same time. Things used to be simple. I agree. Things were much simpler back in the day. Here's how I would understand it today. As of today, this could literally change day to day, week to week. Volta is the current existing architecture that is, basically only used for compute-based platforms. Tesla, server, machine learning, AI. The lowest end part we have seen thus far is the NVIDIA Titan V, which was a $3,000 graphics card, targeted towards machine learning, AI, development, coding, all that type of stuff. Not really intended for gamers, although it did just fine in that regard. Turing is now supposed to be the architecture after Volta for machine learning, and Ampere looks like it's the architecture meant for gaming. Now, I don't have any idea about the timing of these two things are, but it would appear, if these rumors turn out to be true, that we are kind of reverting back to what NVIDIA did previously, which was they had one architecture kind of targeted at that high-end performance, high-end GPU compute audience, and one targeted at gaming. It makes a lot of sense. It makes more sense today than it did back then, because the gap of what compute requirements you have for those is widening, right? You don't need Tensor Core units on your GeForce graphics card. You don't need today HBM2 on your desktop graphics card. Those are useful tools and features and capabilities to have on the professional side, on the enterprise side, on the machine learning side. They take up die space, they affect yield, they do a whole bunch of things negative that would raise the price of the GPU for the gamer. So there you go. Designing one that is more scaled back, more budget friendly, more design friendly from a production standpoint for gaming is easier to do, right? The gaming workloads are well understood. We know how the memory structure works. We know what kind of GPU compute post-processing type shaders you may want to do and those types of things, and so they can balance what that is. Now that's more expensive for NVIDIA because now you're maintaining two chips, two very different workloads, two different driver structures. All of that stuff will have to be maintained separately, but they're making a huge margin and increase in revenue on the machine learning side that they can justify it. On the gaming side, that has been remaining strong. The debate about what will happen with mining and cryptocurrency buyers of GPUs we just don't know at this point, right? If it's April-May timeframe for the next graphics card we see, now some people are saying July-August timeframe for those. The cryptocurrency market could be and will likely be very different then than it is now. So even though I'm sure NVIDIA is developing these products and putting things in place to produce them and stockpile them, they have made no decisions on pricing. They've made no decisions on allocation for partners in different divisions and stuff like that. So your guess is as good as mine, maybe better than mine for now. Next question, ZKid1070 wants to know, why are so few PC games using DirectX 12? Is it more difficult to work with than other APIs? DirectX 12 is more difficult to work with than DirectX 11. It is a much lower level API, which is why you're seeing fewer developers utilize it than maybe you would have expected. But we always knew this was going to be the case. With Vulkan, with DX12, these are low-level APIs that require a lot of knowledge because now you're working at a much closer level to the hardware on the GPU, which gives you the potential to be more power efficient, more powerful, and be able to do more interesting things with the compute power you have given to you from the GPU. But it also creates an extra workload for the developer. We've always kind of said that the expectation was the game engine developers would integrate DX12 support, and then all the licensees would be able just to go from there, right? So anybody that uses Unreal Engine or the Frostbite engine, that once they integrate DirectX 12, all those other game developers will be able to utilize those features without having to know the DX12 capabilities themselves. They take advantage of the engine becomes the new API for a lot of these guys, and I still think that will be the case. It's just a little bit slower than you might have thought. I think most games that are shipping now are going to include DX12 support. I mean, we had Wolfenstein come out recently that only had Vulkan support. It only ran on Vulkan, right? So I think they're taking the API improvements seriously. It's just it's still just a matter of time. I'm hearing some stuff that we may get some more API news in the coming weeks as well. So keep an eye out for that. All right, last question. Ravo K asks, any idea when we'll see 12 terabyte Western Digital Red or Red Pro models? The 12 terabyte Gold has been available since September, but there's no sign of equivalent Red models yet. We have no idea. I asked Alan about this. He basically said he doesn't know when this is going to occur. Western Digital will they'll have it available when they feel like the market is there and ready for them to sell it too. Clearly, you are ready to buy these parts, so maybe they'll see this question, they'll see this video, and they'll be like, damn it, get those 12 terabytes out the door. I don't know if you have that much pull or if we have that much pull, but we'll see what we can do. Higher capacity hard drives, don't get me wrong, I'm all for it, but I think we may be hitting a limit where everybody who's not a crazy person has enough capacity for the time being, but we'll see. We'll see. Thanks, guys, for your questions this week. Again, leave them on the YouTube video here in the comments section or on the comments on the PCPer.com page associated with this video, and we may ask your question next week. Also, don't forget, if you're interested, we did have those t-shirts available at teespring.com/stores/PCPer, and we'll get a shorter URL for you guys next week. Thanks, everyone. See you later.